Welcome to Algebra 1. We're on lesson 7-2, Properties of Exponents Challenge. It is a short lesson, which means we're doing a lesson and a quiz today. Today's date is January 20th, 2021. We have 3 examples, although this one, as already everyone caught and everyone gets their extra credit that caught it, this is supposed to be example 3. Thank you for Ripley, who originally caught that. You're logged in YouTube's history forever and ever. Good job, Ripley. All right. Objective. Diego.
Use multiple properties of exponents to find equivalent statements.
There they are. So yesterday was kind of using one property at a time, maybe 2. This one you're going to use like 2 to 3. All right. So which expressions are equivalent to 8 times 8 times 8? So I'll let you read through those. And it tells you in the instructions, and Khan Academy will do the same thing. You have to choose 2 answers. You're going to circle 2 of these letters. All right. So first, I need someone. Oh, well, I didn't give you enough time. Okay. So the first thing that I want to do is I want to rewrite my original statement. This statement right here as something with an exponent, something with a power. Ripley. Not to the second power. Second power means it's multiplied twice, but I see exactly, yeah. So 3, 8 to the power of 3, or 8 cubed is another way of saying that. Either way is fine. Okay, so that's 8 to the power of 3, but it can be rewritten yet another way. What? Mind blown. 8 as a number, just off to the side as your notes over here. 8 as a number is equal to 2 to some power. What power is 2 raised to get to 8? And you see this over and over again since yesterday. Giorgio, it's 3. Which means if I come back over here, this 8 to the power 3 is really equal to, well, let me rewrite that inside 8 right here. I'm adding parentheses to make it clear what I'm doing. This is 2 to the power of 3. And that was all to the power of 3. Again, if I kind of color code this 3 is the orange 3. This 3, I want to grab that 3 right there. That 3 is the orange 3. Those 3s are the same 3. The inside of the parentheses is the 8. So we're still okay with this. Are there any questions? I know that's the most confusing part of today. That's the new trick. If you see something that can be written as a higher power, like 8 or 27 or 4, rewrite them as a different base, as a higher degree term. Okay, and I'm not done yet because now I can use a property of exponents. You know how to do a power to a power because you might not be masters, but hopefully you're a 4 of 5 or 5 out of 5 understanding. How do I do 2 to the power of 3 to the power of 3? How do I simplify that to just 2 to 1 power? What number goes in that box? And you're going to hold up on your fingers. Is it 6? Is it 9? Some people are saying 6, 6, 9, 9, tiebreaker 9. Ooh, more people are saying, oh, it's a tie again. Half people are saying 6, half people are saying 9. Do you add them or do you multiply them? I don't know. And the answer is it's 9. Thank you for participating. I appreciate it, guys. Yeah, so whenever you have a power to a power, that means you multiply. So here's a question for you guys. What would I have to have written here? What goes here in order to get 2 to the power of 6? With a quiet raised hand. Zeke?
It would have to be either 2 to the second to the third, or 2 to the third to the second.
Yeah, so in terms of powers, but what's the other rule that you could invoke using that one? What would make you add these instead of multiply?
Oh, if you just put 2 and then you put another 2 to the third, because now you would just add them.
Exactly, yeah. So this means multiply, this means add. All right, well, we don't need that second one, so I can kind of cross it off. That was just my example, so ignore it. So the main thing here is that our original statement, this 8 times 8 times 8, this is really as simple as I can make it, 2 to the power of 9. And I take my bow, then we go through the rest of these. Here we go. Let's look at A. A says 8 to the power of 2 to the power of 2. Okay, first of all, I see a property of exponents that I can use. I see a power to a power. What should this be rewritten as with a base of 8? This should be 8 to the power of, and everyone hold up fingers. 8 to the power of, and you guys have, I mean, if you add or multiply, you get the right answer. You're supposed to multiply though. It is to the power of 4. Good. Okay, but this can be rewritten as a higher degree term. 8 is 2 to the power of 3. So again, maybe I'll color code this like I did before. This 4 is going to be my orange. This 8 over here can be rewritten as something, and I'll rewrite that 4. All right, I've asked now like 20 times, I think. Okay, 8 is what? It's something to some power. Let's get someone that hasn't participated yet today. Ashley. 8 is 2 to the power of 2 to the power of 3. Good job. Yes, so 2 to the power of 3. And this is something that we just need to start memorizing. I think by, when is the next lesson that I teach you guys how to memorize these? In the next lesson, I do make you memorize all of the cube roots and square roots all the way up to 22.
What?
Ha ha ha. Oh, not cube roots up to 22. I make you learn cube roots up to 1,728. But still, it's a lot of memorization. So this was one of the easier ones to memorize. Okay, so from here, I see another property of exponents that I can use. I see a power to a power. With a quiet raised hand, what is our final answer for A? How does that simplify? 2 to the, it's, again, the base is still 2. Diego?
12.
2 to the power of 12, because you multiply 3 times 4. Okay, and then I zoom back out. Okay, we're looking for 2 to the power of 9. This is not 2 to the power of 9. That's 2 to the power of 12, so that's not the answer. Cross it off. No, it's not A. That's not 2 to the power of 9. Let's go again. Let's look at part B. All right. Using properties of exponents, your rules of exponents, however you want to say that. Ooh, I have division now with the same base. Okay, well, obviously, I'm going to have the same base. It's still 8. But what number goes up here for the power? Everyone can use your fingers for this one. What power should go up here? It's 4. Good. You subtract. And if I'm showing my work, it's really 9 minus 5.
Wait, would that be the same answer? So it wouldn't be
Yes, good observation. If you could raise your hand next time, I'd appreciate it more. But yeah, that's a great analysis. Yeah, 9 minus 5 is 4. And yes, you can see, oh, if you compare 8 to the power of 4 in this previous step to 8 to the power of 4 right now, we'll just go ahead and skip ahead. We know this is eventually equal to 2 to the power of 12, and we can cross off B. Since we know we're supposed to choose 2 answers, we know that the answer is going to be C and D. But let's analyze why. So the problem with both of part C and D is they're not the same base. I have a base of 2 and a base of 4. I cannot use a property of exponents. And this is something that Giorgio pointed out on our first day. So how could I somehow manipulate this so that I can use properties of exponents? Go for it, Zeke. What's your idea?
I was gonna say, if you could convert that, like, up it, so it would be 4 to the power of a different number, but it would be the same equivalent, but you can't get that.
Okay. You're really close to the idea, though. So again, I'm not going to change this first number. I'm going to rewrite it. This is just 2 to the power of 3. But this 4 to the power of 3, I can rewrite. Did you just figure it out?
Yeah.
Okay, tell us.
So you would bring that 4 down to a 2 to give you the same base, but to do that, you have to up the exponent so it would be the same. 4 cubed would be, what is 16 times 4? A big number.
64.
64, okay. And then, so 6, 2 to the power of 6, because then that would get you the same answer, 4 to the power of 3. Oh, I just realized you could cut the 4 in half. Okay.
So you have the right idea. It is 2 to the power of 6. I'm going to show you guys an easier way to do what Zeke did. You did the long, harder way, which is awesome because it shows me you're really good at mental math. I might not be as good as mental math as you. So I'm going to do it an easier way. 4 is 2 to the power of 2. And this is still raised to the power of that original 3. I believe what Zeke did in his head is actually 4 cubed mental math and not memorization, which is awesome. And then he converted that back into 2 to what power? So good job. This way, yeah, you just rewrite 4 as a higher power. That's 2 to the power of 2. And then again, I use properties of exponents here. So I'm going to rewrite this 2 to the power of 3. That hasn't changed, 2 to the power of 3 times. But this second term can change. Braden, what is it? The second term right here is going to be 2 to the power of, what do I do? Do I add them? Do I multiply them? If you add them, that means you're doing 2 to the power of 2 times 2 to the power of 3, and then I would add 2 plus 3. And you get, there it is. Yeah, thank you. Yeah, so we do indeed multiply them. We get 6. And then we do that property that I said before, if someone else can help me. I have the same base, and I'm multiplying. What do I do with my exponents now? This is going to be 2 to the power of, you can actually do fingers. Everyone do fingers. 2 to the power of, is it, well, I guess if it's fingers, I kind of give away. It can't be 18. How would you do 18 on your fingers? Maybe binary? How do you, I don't know. It's 2 to the power of 3. There it is. Yeah, you guys all have it. 2 to the power of 9. You just add them. 3 plus 6 is 9. And lo and behold, if I zoom out here, that was what we were looking for. We were looking for 2 to the power of 9, so it is an answer. We have verified it. Woohoo! Pat ourselves on the back, and we move on to part D. All right, same process as before, although this one looks like it's not an answer. Wait a second, the instructions were wrong. D is not an answer, and you can kind of see right off the bat that it doesn't work. So these notes need to be fixed. Sorry about that. Let's see why. All right, so 2 to the power of 1, I can't do anything. I'm going to leave it at 2 to the power of 1. But this 4 to the power of 2, I can convert this so that it has a base of 2 again. Let's see if you guys have picked up on the trick yet. I know Zeke knows how to do it. He is doing really well. I want to hear from someone that I'm not 100% on. How do I convert 4 to the power of 2 to have a base of 2? You need to write it as a higher degree term. So I kind of have the setup here as a hint. If I want to rewrite 4 to the power of 2, well, power of 2, that's still the same. 4, this thing needs to be 4. How do I write that as a base of 2? Yeah, Berkeley? 2 to the power of 2. Just like the last one. 2 to the power of 2. All right. And then we continue on. I'm going to rewrite this 2 to the power of 1. It has not changed yet. Still the same. That's still 2 to the power of 1. Times, okay. Again, this is the new thing that I'm going to change. 2 to the power of 2 to the power of 2. There's lots of 2's there. What is this thing? 2. It's 2 to something, right? 2 to what, though? And you guys can do this with your fingers. I think if you add or multiply, you're still going to get the same answer. So everyone should be holding up indeed a 4. But was it multiply or was it add? What were we supposed to do those? You can also go like this or like this, I guess. You could do it with your fingers. You guys got it. Yeah, it's multiply. You're supposed to multiply. 2 times 2 is 4. And then finally over here, this is going to be 2 to the power of, use your fingers, 2 to the power of, fingers, finger math, 2 to the power of 5. Good. 4 plus 1 is 5. And you can see that's not an answer, so these instructions need to be changed. Or what Mr. Sindel could do is I could change this 1 to a 5 for next year's notes, and then this would work out. So I'll change that for next year and make that a 5. But for us, there's only one answer, and I made a mistake. So lots of mistakes on this one. All right, give me a fist of 5 on example number 1. How well could you follow that? really well, 5 out of 5, not really well, 1 out of 5. Where are we at? Where are we at? Oh, I'm getting 4s and 5s all around. No one's at a 3 or less. Oh, well, that's awesome. Okay, let's move on to example 2. Unfortunately, there's no button in Zoom right now to say, go faster, Mr. Sindel, or go slower, so I don't know speed. All right, let's do example 2. Apparently, Wyatt is solving this one. Here's the problem that Wyatt's solving. Looks good. Okay, so he rewrites the problem. Did he rewrite it correctly? Looks like, okay, same thing. And then he does step 1, 2, and 3. We're looking for a mistake. If there's no mistake, then you can say there's no mistake. That's answer A. So I want you to take some time, see if there is a mistake. I'm not going to rush you, though. All right, I think that was enough time. So was there a mistake? Let's just go ahead and do a yes or no. Let's say mistake is thumbs up. No mistake is thumbs down. Was there a mistake? No mistake. Take a vote. Most people are saying thumbs down. There's a few people saying some thumbs up. Let's do Haiti and Jose are not cameras on, so I can't tell them. All right, so thumbs down. If I call on you, then you just gonna say there's no mistake, so there's nothing calling. Let's call on someone that has a thumbs up. Let's call on Giorgio.
On the 6 to the power of 0, when the step 3 be 1,
Oh,
everything to the power of 0 is 1.
you guys see that? Check this out.
I do.
Oh, nice. So Giorgio's claiming, hey, on step 3, when Wyatt is trying to get from 6 to the power of 0 down here, anything to the power of 0 should have been a 1. So there we go, D. Although, again, Mr. Sindel made a mistake. There's actually 2 mistakes in this one. Khan Academy, there will only be 1 mistake. And I realize I put in 2. I don't know why, but this is me 2 years ago and me not catching these mistakes. Zeke, what's the other mistake?
I don't know, but could you combine the 3 and 2 to make that 6? Like, is that something you can do or no?
That's a great question. And I'm realizing that's actually not a mistake. Let's talk about why. This is okay. 3 to the negative 5 times 2 to the negative 5 is 6 to the negative 5. And you might be saying, that's not a property of exponent we ever learned. How is that possible? It is. It's 2 properties of exponents. Let me do the long steps over here. So if I have 3 to the power of negative 5 times 2 to the power of negative 5, this is equal to 3 times 2. And I'm going to factor out, I'm going to do one of the rules in reverse to the negative 5. Because remember, our rule states that if I have something on the outside with 2 different bases on the inside, I'm allowed to distribute this as a power to get back to this previous step. I'll let you think about that for a second. If I have 2 different things in here being multiplied that are different bases, you can see that 3 and 2 are not the same number. If I have a power on the outside, I distribute it as a power, and then both of those are to that power. I'm doing that step in reverse. You're allowed to go either direction with these rules of exponents. And now check it out. What is 3 times 2? 6. It's 6 to the negative 5. So I thought that was a mistake, and I'm wrong. That's actually okay. So it's a rule. It's 1 rule of exponent, not 2. 1 rule of exponent, just in reverse. Yeah, that's tricky. But yeah, the main mistake was anything to the power of 0 should be 1. And let's move on to example, not number 2 again, but example 3. And we'll be done. Which expressions are equivalent to 2 to the power of 7 over 8 to the power of 7? Ah, Mr. Sindel, those are different bases. We're not allowed to do that. But I taught you guys already, you can make them the same base with a trick. If you know the trick, go ahead and do it, and then you can begin the homework a little bit early. How many people know the trick for example number 3? Zeke knows the trick. Anyone else know the trick? How do I write these with the same base? Ripley knows the trick. I just called on you last time, so I know you know it. Alden, you want to try doing this one for us?
Sure. So you like separate this exponent and 2/8. So you do 2/8. And then you put that in parentheses. And then you put the exponent outside.
Nice, using the property of exponents in reverse. Yeah, way to go. Okay, keep going.
Keep going.
Yeah, I'm curious because I didn't actually think about doing it this way, and this is going to work.
Okay, so you do 7 times 2/8.
Not quite. So if you're gonna do to the power of 7 again, then you're just kind of going backwards to this step, right? But you can reduce this. What is 2 divided by 8 reduced to? Reduce that fraction.
It's
1/4, yeah. 1/4, and still to the power of 7. And then you can put the 7 back on the inside. You can say that's 1 to the power of 7 over 4 to the power of 7. That's actually super clever. I've never seen anyone try it this way. All right. My question for you guys is, what is 1 to the power of 7? You can do it with fingers as well. So people are holding up 7. Some people are holding up 1. The answer is 1. What's 1 times 1? What's 1 times 1 times 1? What's 1 times 1 times 1 times 1? What's 7 times? It's 1. Yep. So this is over here, 1 over 4 to the power of 7, which is pretty cool. It doesn't give it away yet because I haven't simplified it all the way. But eventually I want to write everything with the most simple base possible. I want to rewrite everything with a base of 2. Can anyone rewrite this denominator in our fraction as a base of 2? This is equal to, well, what happened there? This is equal to 1 over 2 to some power. And maybe I'll just write 2 to some power to the power of 7. Maybe that'll give it away. 4 can be rewritten as 2 to the power of, and you guys can all hold up fingers. Uh-oh, only one person knows what 4 is. 2 to the power of what is 4? No. And I should turn this back on. No. 2, yeah. Which means I can finally rewrite this as its final form, 1 over 2 to the power of 14. You multiply the 2 times 7. All right, I'm gonna leave it like that. I will write one other equivalent form because, again, maybe you don't like fractions. There is a way to get rid of fractions by taking the reciprocal. You're allowed to take the reciprocal with rules of exponents, with properties of exponents. You can say this is also equal to 2 over 1 to some power. Does anyone know what power I would have if I took the reciprocal? 2 people know. Diego? Okay, Ripley? Not quite. When I take the reciprocal, maybe I should open up our previous notes so we can take a look at them. 7-1, all the notes. Oh, I'm getting something in the chat as well. Not quite, Jose.
No, that was the last one.
That was the last one. Okay. It's this one right here. This is the property that I'm looking at. The take reciprocal property. What is it, Alden? -14. There it is. Whenever you take the reciprocal, just make the exponent or multiply it by -1. If it was a positive, make it a negative. If it was a negative, make it positive. Every single time that you take the reciprocal, just multiply the exponent by -1. So really what I'm saying is our final answer here could have just been 2 to the -14. These two are equivalent. Those are kind of our two forms that we're looking for. All right. So I need to go through each and every one of these letters and figure out what's going on. Okay, let's do A. It's a reciprocal. Let's go ahead and make that a not reciprocal, or we don't have to. There's a bunch of different steps that we can do. Maybe we want to rewrite the 4 as a base of 2. If everything is a base of 2, then we're ready to go. Let's write A as 1 over what? What to what power? 2 people know. I haven't heard from Carlos yet today either, or Haiti. Actually, Haiti did do a Fissa5, but she hasn't done an answer yet. Carlos, you want to give this one a try? Let me try my Spanish. 4 es un número 2 a la podre de qué? ¿De qué número? No sabes? Oh, okay. Can someone help him? ¿Entiendes la pregunta? Okay. Someone help him. Alden, help him.
Just like so the answer.
Yes.
Okay, so it would be 2 to the 7.
The power of 2, yeah. All right, and we're basically done. I can rewrite this as 2 to the power of -2 as well, because I can take the reciprocal and make it a negative power, but you'll definitely see if I zoom back out here, 2 to the power of -2 is definitely not equal to 2 to the power of -14. I can cross it off. All right. Let's move on to part B. Check this out. Ooh, I have a -6 to the power of -7. So the dead giveaway for B is there's no way to rewrite B to write 6 as a base of 2. I mean, I could do something like this where I go a -3 times 2, all of this to the power of -7. But you'll never be able to get rid of the -3. You'll never just be able to have only a base of 2. So we can cross that one off immediately. There's no way to get rid of that 3. You can only have a base of 2. That's what we're shooting for. All right, let's try looking at C. 4 to the -5. Again, I can rewrite this. I want to rewrite this with a base of 2. 2 to some power. I can say 2 to some power to the power of -5. All right, Haiti, I have to call on you. What power should I have 2 to the power of? 2 to the power of what?
2.
Yeah, there it is, 2. And Haiti again, 2 to the power of 2 to the power of -5. What do I do with these? Do I add them? Do I multiply them?
Multiply.
Yep, and you get?
-10.
Careful.
-10.
Good. -10. All right, and Haiti's answer 2 to the power of -10 is correct, but it's not matching 2 to -14, so we can cross it off. It's, again, my choose 2 answers thing. I did not really think about this going into it. It's not that one. Let's look at answer D. 2 to the power of 7 times 8 to the power of -7. Well, this one is pretty cool because I can rewrite 8 to the power of -7 as a reciprocal. I can flip it. Let me do some side work to show you guys what's going on. 8 to the power of -7 is really the same thing as 8 to the -7 over 1. I can just have everything over 1. If I flip it, if I take the reciprocal, that means I don't have a negative power. This can be equal to 1 over 8 to the power of now a +7. That's my reciprocal rule, my negative power rule. So I can rewrite this fraction or rewrite this problem as 2 to the power of 7 times 1 over 8 to the power of 7. And just like I did before, I can write anything over 1. And when I'm multiplying anything, you just multiply straight through. Like multiplying fractions, I multiply straight through. So the top, the numerator is going to be 2 to the power of 7. The denominator is going to be 8 to the power of 7. And I'm done, because look at what the question was asking. 2 to the power of 7, 8 to the power of 7. I don't even need to do anything else. I'm done. The correct answer here is D. All right. There's no backside of the notes today. That's all we have. Can everyone give me a fist of 5? And I'll look at the chat as well. How well can you use properties of exponents to find equivalent statements? Everyone's giving me 4s and 5s. I'm looking at the chat. I'm seeing a 4 and 4. All right. Thank you.